it's going to be easier, or should be kind of easy. It shouldn't be anything too difficult. So I'll try my best to try to make this as easy as possible for you to understand. So in many applications of vectors to physical problems, we must find the combined effect or sum of the resultant of two or more vectors. What, for example, is the combined effect of two or more forces acting on an object? How does wind velocity affect the velocity of an aircraft? Those are some problems where we may have to use some vector addition. So let's consider an example. So consider Sarah, who wants to take the shortest possible route to get from A to C, and Amy, who likes to exercise and wishes to follow the sidewalk around instead of cutting through the park. Soon they both start walking from A to get to C, which is across the park. So this is how their diagram would be drawn. So as you can see, Amy is going to go all the way around. She's going to go from A to B. So Amy is going to go from A to B, and then she's going to go from B to C to get to the park. Well, Sarah just literally wants to go across, which is AC, which is also the same thing as saying vector AB plus vector BC is equal to vector AC. As you can see, this kind of works in terms of kind of canceling out. So as you can see, to get vector AB plus vector BC gives me AC, which means that the second part of the first vector cancels out with the first part of the second vector, which means that I'm just left with vector AC. This is going to be something that you probably will see a lot in vectors. So it's called the triangle law. So for vectors U and V, the sum or resultant of vector U and vector V is a vector from the tail of U to the head of V when the tail of vector V is placed at the head of vector U. So I have my vector U over here. This is my starting point, my tail. This is the head. And then vector V starts at the head of vector U and goes upwards like that. And then U plus V meets at the head of vector V. So vector U plus vector V is the same thing as saying vector U plus vector V. Okay, no, when you trace around the triangle, the resultant is always going the opposite direction. So now we have the parallelogram law. So sometimes it is more convenient to use this method when showing the sums of vectors starting at the same point. So we draw the vectors tail to tail and then complete the parallelogram with these vectors as sides. The sum resultant of the diagonal of the parallelogram from the point where the tails are joined to the points of the head where they meet. So what I mean is, I'm going to start, this is going to be my reference point. Vector U is going to go this way. Vector V is going to start at the tail of vector U and go the opposite direction. And the resultant is where both the heads of vector V and vector U meet at the diagonal of the parallelogram. Okay, so as you can see, that parallelogram gets split up into two triangles. So how could we show vector subtraction for U minus V geometrically? So vector U minus vector V is the same thing as saying vector U plus negative vector V. So what I mean by this is U is going this way. From what we see in our diagram above, we know V is going to the right. How would vector negative V look like? If we remember from yesterday or from Tuesday's lesson, how would vector V end up looking like? How would it be drawn if you were to draw it? Does anyone want to give an answer to that? How would vector v be drawn? Negative v. Same magnitude, opposite direction. So if I were to draw this geometrically, my u starts at the same point. However, my negative v would be coming this way. U would still be going this way. And negative v would be going that way. Which means that my diagonal can be vector u minus vector v, which could be from here to here, if we wanted to, since it meets at the two heads of u and negative v. The resultant would be u plus negative v. So remember, if you're drawing the negative vector or something, it's just the same magnitude, but going in the opposite direction. Now, however, the angle between the two vectors is always the angle formed when the vectors are placed from tail to tail. That is starting at the same point. Okay, so from tail to tail, that is what our angle is going to be. Usually, it's going to be less than or equal to 180. So as it's simple addition and simple subtraction, there are vector properties of addition. So for example, the commutative property, which is vector A plus vector B, is the same thing as saying vector B plus vector A. An example would be if A is 5 and B is 3, 5 plus 3 is 8, 3 plus 5 also gives me 8. Doesn't matter which way I arrange them. 5 plus 3 and 3 plus 5 will always give me the same answer. Then we have the associative property of addition. So if I have vector A and B in brackets, and then C outside of the bracket, it's the same as saying vector A plus vector B plus vector C in brackets. So adding the 0 vector would be vector A plus vector 0 is equal to vector A. So now let's take into consideration the combined effect of a vector and its opposite is the 0 vector. So for example, if we have vector A plus vector BA, so its opposite is going to equal the 0 vector. Or vector A gives me 0, its magnitude is 0, and its direction is undefined. So for example, here we have vector BA, and then we have vector AB plus vector BA. These things cancel out, which gives me vector AA, which gives me my 0 vector. So that is the 0 vector. Now, we're going to get into vector addition. So I want to find the magnitude and the direction of the sum of two vectors, vector u and vector v, if their magnitudes are 55 and 37, respectively, acting at an angle of 30 degrees towards each other. So because I'm finding the sum of two vectors, okay, we can assume vector u starts at the tail over here. This would be my vector u. And vector v also starts at that same tail, but goes horizontally. This would be vector v. Now I can draw my parallelogram. and I need to get the magnitude of the resulting vector. But because vector u and vector v are acting at an angle of 30, which means angle uv, which is right here, this is going to give me 30 degrees. Okay. However, when I draw my resultant vector, this 30 degrees gets split up into two angles, theta and that other Greek symbol. So I know that the magnitude of u is 55, and the magnitude of v is 37. So the reason why u is 55 and v is 37 is because of the fact that it says if their magnitudes are 55 and 37, we always assume that the first magnitude has to do with the first vector, which is vector u, and the second magnitude has to do with vector v. So I have an angle of 30 that is shared between the resultant. What would this angle be, just using basic angle laws? What would that angle be? That looks like an obtuse angle, Priyanshu. It's not going to be... Did you mean to say 150 or 15? I can't assume it's exactly split in half. So what would my top angle be? The obtuse angle I just drew. $150. So now, in order for me to find this angle over here, what do I need to find? What can I do to, no, not finding the angle. What can I do to figure out my resultant vector? Remember, this is u plus v. What can I do to find my resultant vector? What law, sine or cosine? We're going to be using cosine law. So the magnitude of u plus v squared is equal to 55 squared plus 37 squared minus 2 times 55 times 37 times the cos of 150, because that is the angle that we can use, because 30 is split up into two spaces. So we can't assume it's just exactly half. So this gives me approximately 7,918.72. But when I square root it, the magnitude of u plus v is equal to about 88.99 units. So now I need to figure out what the angle is where my resultant vector happens. So I need to find angle theta. So sine theta is equal to, sine theta over 37 is equal to sine 150 over 88.99, which means theta is approximately 12.00 degrees. So my therefore statement is therefore magnitude of u plus magnitude of v is equal to approximately 88.99 units, 12 degrees relative to vector u. The reason why it's relative to vector u is because we found theta, which is the angle that is corresponding to vector u going this way. However, if we were to find it for this sign over here, it would be u plus v is equal to 88.9 units. It would be 30 minus 12 degrees, so it would be 18 degrees relative to vector v, if we were to find it for the other side. So the next one doesn't really have to do with finding any values. A rectangular box has parallel faces, A, B, C, D, and E, F, G, H. We find a single vector equal to each of the following. So my reference is going to be vector AB. So vector A to B. So this is going to be vector A, B. So first of all, we start with vector AB. And then plus vector AD. So because we have this B over here, I need to find a vector that starts at the vertex B and goes somewhere. So can someone tell me the equivalent of vector AD that starts with B? Vector BC, thank you. Thank you, Lauren. Vector BC. And then plus vector AE. So we'll do it step by step, which means that my B's cancel out. So vector AB plus vector BC is the same thing as vector AC. Plus, now we need a vector that's equivalent to vector AB, but it's AE, sorry, but its starting point or its tail starts at C, at vertex C. Who can tell me what is an equivalent vector to vector AE that starts at the vertex C? Thank you, Mohammed. CG. So this is vector AE right here. This is the same thing as saying vector CG. And this equals our C cancel out. This is equal to vector AG. So vector AB plus vector AD plus vector AE is the same thing as saying vector AG. So now the next one we have is vector HE minus GA plus vector FC. So how can I change negative GA for it to become a positive vector? How can I rewrite negative GA? How can I rewrite vector negative GA? How can I rewrite that? As AG. Thank you, Mohammed. Wait, why did I move all the way down there? Hold on. Let me just press Control V on this thing. There we go. Okay, that was weird. So thank you, Mohammed. I'm going to rewrite this. Why are you not working on me? So I can write this as equals to vector HE plus vector AG plus vector FC. Now let's see what you guys come up with. Can you guys simplify vector HE plus vector AG plus vector FC? Tell me what single vector is the equivalent to all those three being added. Okay, so Muhammad got vector EG. Did anyone else get a different answer? Okay, anyone else get EG or AC? All right. So vector HE is also the same as saying vector DA. The A's cancel out, so I get vector DC plus vector FC. FC is the same thing as saying DC. Oh, DG, sorry, DG, whoops. So it'd be vector DG. So vector DG plus vector. Sorry, I can just do this. So it's the same thing as saying vector AF. My apologies. So DG is the same thing as saying vector AF plus vector FC, which is the same thing as saying vector AC. So example 3 is a proof question. Yeah, that's fine, Mohammed. That's totally fine. As long as they're equivalent vectors, that's completely fine. There can be multiple answers for the same question. So example 3, I want to show that the magnitude of u plus v is less than or equal to the magnitude of u plus the magnitude of v. So I have to split this up into two cases. So I have case 1, which I'm going to use the triangle inequality theorem. So case 1, so we're going to assume if vector u and vector v are non-collinear, then that means vector u, v, and u plus v form a triangle. Okay, so if vector u and vector v are non-collinear, then vector u and vector v and u plus v form a triangle. So, which means that according to triangle inequality theorem, vector u plus v which is the resultant, has to be less than vector u plus the magnitude of vector v. Which basically means that if I have a vector going this way, this is my vector u, and this is my vector v, I have to make a triangle, which is vector u plus vector v. So for example, when I have my triangles, does anyone know what the perfect, what's it called? Can anyone name me a perfect Pythagorean triple? Besides that, I mean, that would work too. I think 3, 4, 5, okay? So for example, if I have, let's say, the magnitude of u is equal to 3, and the magnitude of v is equal to 4, and let's assume it's a right angle triangle, which means that the magnitude of u plus the magnitude of v give me 5. This theorem states that 5 is less than 3 plus 4. 5 is less than 7, which means it is true. So my longest side, which is the resultant, has to be less than the combination of the two other vectors being added together separately. And as I can see here, this is going to be an example. Okay. Now I have to do a case 2 where I can find out where u plus v is equal to the magnitude of u plus the magnitude of v. Let's go to case 2. So let's assume if vector u and vector v are parallel, the triangle collapses to a straight line. And I'll show you what this means. So what this means over here is if I'm parallel, I have my vector u, which is over here, and I have my vector v, which starts at the tail, at the head of u, and goes this way. So this is vector v. I can therefore say vector u plus vector v results when I add those two together. So what I'm really proving here is that the magnitude of u plus v is equal to the magnitude of u plus the magnitude of v. Okay, because it's a single line, I don't really have to do anything with triangles and angle theorems, so I can safely assume that vector u plus vector v is the same thing as saying vector u plus vector v. Which means I have proven that the magnitude of vector u plus vector v is less than or equal to the magnitude of vector u plus the magnitude of vector v. Is everyone good so far? Any questions, thoughts, or concerns? Okay, if there's no questions, I will be moving on. Why is this thing so glitchy today? Holy smokes. Oh, it's because my cursor is there. So example 4, last example, given the vectors A, B, C, construct the vector A minus vector B plus vector C. So the only one that's going to be going in the opposite direction is vector b. So negative vector b is going to look like this. So because it's in the opposite direction, this is negative vector b. So I have vector a, which starts here. So this is vector a, nothing changes about it. Minus b goes from the head of vector a and goes horizontal. So this is negative vector b. Vector c has no change in it, so it goes this way. This is vector c, which means that my resultant vector is going to be vector a minus vector b plus vector c. So as you can see, adding vectors isn't really too difficult to do. It's only when you start getting into the concept of finding direction, using like north, 50%, 50 degrees east, all that stuff. When it comes to the physics stuff, then it starts getting a bit confusing. But just overall, simple addition, multiplication of vectors isn't too difficult. So the next lesson we're going to learn is about multiplying vectors. So we're going to be multiplying a vector by a scalar. So that's what the next lesson is going to look like. So I'm going to stop recording this, and then we'll move on.